So 3D figures. 3D figures can basically be divided into three different categories. Three different categories of three-dimensional figures that we're going to talk about. One are, so let's see, 3D figures. We have some with the two base. We have the two base group. We have some with two bases. We have some with a single base. And then we have none with no bases. We have some with two bases, some with one base, and some with no bases at all. Now, in order to kind of push forward, I need you to understand kind of the parts of a three-dimensional figure. Polyhedrons, anybody know what a polyhedron is? Alex? No, that's not an exactly good definition. Jaden? A flat-sided object, three-dimensional object. They cannot have rounded surfaces. So a polyhedron is simply a multi-sided three-dimensional object with only flat sides. That's what a polyhedron is. Okay? So when we're talking about polyhedrons, they have different parts that we're going to need to deal with. Okay? Yes, ma'am? Polyhedron. Poly, P-O-L-Y, hedron, H-E-D-R-O-N. It is a three-dimensional, multi-sided, multi-flat-sided object. Three-dimensional, multi-flat-sided object. You can't have rounded sides. So no spheres, no cones, no cylinders. So basically prisms and pyramids. Triangle is not a three-dimensional figure. No, it can't. It's not called a triangle. A triangle, by definition, has three angles. If you only have three angles, you cannot be in three dimensions. Triangle.
Prisms and what?
Prisms and pyramids, basically. Prisms and pyramids. Phone a friend. Okay. Then look it up later. Here we go. So, the two-based shapes include, let's see, I'm going to put up at the top. So we have prisms. Nope, hold. So in the two bases, you have prisms. Prisms have like a specific description. They have two congruent and opposite bases. A prism will have two congruent opposite bases. That means they are exactly the same shape and size. And by the way, it's how it gets its name. If it is a rectangular prism, then the bases are rectangles. If it's a triangular prism, then the bases are triangles. Okay? Has two opposite congruent bases. And it only has what are called rectangular faces. Now a face, the face of an object are the sides, not including the bases. So I'll give you a quick example. If you have a rectangular prism, looks something like this.
But it also has square faces?
Yes, because a square is a rectangle. Remember we learned that last unit? A square is a rectangle. So a cube is considered a type of prism. Alex?
Is there a diagonal prism?
Sure there is. Because if you can have a hexagon, then you can have a hexagonal base. So for example, if in this rectangular prism, if I decide that this and this are the bases, remember the bases must be opposite and congruent, then all the other four sides are considered faces. The faces are the non-base sides. The faces are the non-base sides. There are other parts to polyhedrons. They have edges and they have vertices. What's a vertex? Easy definition, Brendan.
When two lines of an object meet.
Give me a more simple, a definition that kind of explains it better.
Corner.
A corner. Perfect. A vertex is a corner. A vertex is where edges meet. What's an edge? Leilani? It's where faces or bases meet. So this is considered an edge. This is considered a vertex because it's where the edges meet. Alex? Now, there's a really cool way to determine if you've counted. By the way, on this one, how many vertices are there? Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Agreed that there are 8 vertices? No. Every rectangular prism has 8. How many edges are there, Alex? There are 12. And how many faces are there? And let's include the bases. Cameron?
6.
There are 6 because there are basically 6 sides. Now, and I'll get to your question in just a second, Brendan. There is something called Euler's formula. E-U-L-E-R apostrophe S, Euler's formula. And a lot of kids don't know about it, but it's a really cool way to test to see if you have, whenever you're asked about the number of edges and the number of vertices and the number of faces on any particular object, any polyhedron, then here's what the formula says, that if you take the number of faces that you have and you add the number of vertices that you have and you subtract the number of edges that you have, the answer will always be 2. So we'll plug them in. F is 6 plus 8 minus 12 equals 2. And we'll keep checking, and I'll show you how Euler's formula works with any polyhedron. Works with any of them. And the way I remember the order is I think fave without the A, F-V-E. So F plus V minus E equals 2. Leilani? Nope, it's just the way that the math works.
So you can.
Bennett?
Why not 5? But it's a word.
Okay, that'll work too. I'm just telling you how I remember it. Yes?
So is vertices the plural of vertex?
Yes.
Okay.
Yeah, it is. Yeah, vertices is the plural of vertex.
That's what
Okay.
I thought.
Yes, sir? Alex, you have a question? Okay, so on 2 bases, we have prisms. And by the way, again, they're named after their what? They're named after their what? The bases. By the way, another way to think about a prism is if you slice it into a whole bunch of slices like a butcher, if you're slicing between the bases, they will always be congruent pieces. And I'll show you how this works out. So say we have a triangular. Let's go to a triangular, right? And this, triangular prism, right? And we have our bases right here and right here, right? Because they have to be opposite and congruent. Nolan?
So it'd be like a loaf of bread.
It's like a loaf of bread or a thing of bologna. So if we start slicing like this, chop, 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 we end up with a bunch of congruent pieces. That only happens with prisms. It does not happen with a pyramid. That only happens with prisms. So it's a good way to test to see if you have the bases located properly. If you were to slice it like this, like slice, 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 yeah, you don't end up with congruent pieces. In fact, you end up with a bunch of trapezoids until the middle one's like a rectangle. It gets all weird. So if you slice between the bases, you get congruent pieces. Any questions on prisms? So how many bases for a prism?
2.
Muy importante, 2. Now there's one other object we're going to study that has 2 bases. What is it?
Wait,
Cylinder?
It is a cylinder,
but that's not a poly.
but it is not a polyhedron. But a cylinder does have 2 bases. Has 2 congruent opposite bases that have to be circular. in a prism or in any of the two base, yes,
What if you like or a cylinder? Not what
yeah, two
you
base.
have to cut in the middle, or
What?
can you just cut anywhere between the two bases?
You just start slicing. I'm saying you just get the same shape,
Oh.
okay? If that confuses you, don't worry about it, okay? So both cylinders and prisms are two base objects. The requirement on the cylinder is that you have a circular base. You have a circular base. Good to go?
Yes.
Okay. Single bases. We'll start with our pyramids. Now, pyramids have a single base. They have one base. And what is called an opposite common vertex. They have an opposite common vertex. Have an opposite common vertex. Alex?
What about cylinders or prisms where the two bases are not?
We're not going to get in. Well, the bases have to be congruent, or they're not prisms. There's something else. Yeah, it is a requirement that they have two opposite congruent bases. If they're not congruent, it is not a prism. Okay?
What about for a cylinder if the bases are not?
It is not a cylinder. It's something else. Okay? Yeah, it means it's something else. Now you have one base and its opposite a common vertex, and you have triangular faces. Triangular faces with a pyramid. I'll show you what I mean. I have this is a rectangular or square pyramid, depending on how it's marked. It is still named after its base. And if you look at the sides are, the faces are triangular. The faces are triangular. See what I mean by a common vertex? So the base is opposite that common vertex. The base is opposite that common vertex. Now, let's talk about, do the bases have, for a single one, there's only one base. The faces, no, they do not. They do not have to be congruent. Think about a rectangle. Think about a long, skinny rectangle. Those triangular faces would not be congruent. Yes, sir? Go ahead. Now, let's do our Euler's test on this. If you include the base, how many faces are there on this triangular, on this square pyramid? Jaden? 5. How many vertices are there? 5. 1, 2, 3, 4, 5. How many edges are there? 1, 2, 3, 4, 5, 6, 7, 8. What is 5 plus 5? Minus 8.
22.
Still 2.
Could that be used to like find one of them like the same size as
It can be. What it's really better used for is if you ever get a question where it says, this kind of an object has this many faces, bases, and edges, you will find that almost all the time you can eliminate at least 2 answer choices, usually 3, just by seeing if they meet Euler's formula, because they have to. I know, because the person writing the test doesn't really take that into account, that you don't even have to know what the shape is. You just take the number of faces they give you and the number of vertices and add them together and subtract the number of edges. If it doesn't equal 2, you can eliminate that answer choice. Has to. I know, it's funny, isn't it?
It's kind of like we're like.
Yeah, it's kind of like a cheat.
Yeah.
I know! I love cheating. It's a cheat.
Cheating and using your
Yes, it's using your resources. Okay, by the way, the other single base is a cone. The other single base is a cone. Again, the only difference is your base is still opposite your common vertex, although it's not really a vertex because it's not the meeting of edges. It's just a circular base, and then it just goes up into that point. I guess you can still call it. No, it's not a common vertex. A vertex is a meeting of edges. I don't really know what it is. It's the pointy thing at the top. Yeah. Alex.
And the top part,
Yeah?
if you unravel it, it'll always equal part of a circle.
Yes, it will. It will. Okay? And then there's only one object. Really, there's only one basic object that has no bases. It's a sphere. A sphere has, now they may say a half a sphere or a quarter of a sphere, but at the end of it all, it's all about a sphere, huh?
Half a sphere still has base, right?
No, it does not. It does not. It does not. It's not called a base. I promise it's not called a base. Okay?
When I think of shapes like these, I think of like when I was in preschool and they had those foam shapes.
Yeah.
Oh, those were weird. The wooden
All right.
base.
So, when you're looking at an object, when you get a three-dimensional object, the first thing I always check for is to see if there's that common vertex, or better yet, the pointy part. That's the not mathematical way of describing it. But if there's a pointy part, then there's this pointy party thing, then it either has a single base. So I go opposite the pointy thing, and whatever that side is opposite, that is my base. This would be called a what? Triangular pyramid. Triangular pyramid. Name it after the base. Triangular pyramid. Okay? How many faces are there? 4. How many vertices are there?
4.
How many edges are there? Euler's works. Okay? So we're going to do 2 things today. Alex?
I've noticed on prisms, there's always the same number of vertices as there are faces.
That's an interesting observation. So here's what you're going to do. You've got 2 worksheets. One's a homework sheet, one's a class worksheet. Now, I want to explain the class worksheet. You're going to fly through it, and I'm perfectly cool with that. It's front, back. There is a key. So when you're done as a group, I want you to go check it against the key. When you can work in your groups, okay? You don't have to, but you may. Okay, Jonah, listen up so you can hear everything. Once you're done and you check it against the key, you may discard it and pick up the homework, which will be on the desk next to mine. That I want you to do independently, okay? It's basically counting faces and vertices and edges and all that fun stuff. You should still be able to fly through it with no problem at all. We'll do the cutouts tomorrow. Oh, she's coming back. Sit in your group, Ciara. Gavin. This is what I'm talking about. It is very easy. You should be able to fly through it. Okay? Just make sure you use the key, please.